Hello, in this lecture we'll answer on two questions. In the first question, we'll find out the length of line segment X that is inside a rectangle ABCD. And in the second question, we'll find out the value of the green area that is inside a semicircle. We start with the first question. In the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle. We know that the length of the tangent from point A to the circle is equal to 33 degrees. The length of the tangent from point B to the circle is 85 degrees. The length of the tangent from point C to the circle is the length that we are looking for. It is unknown, it is equal to x. And finally, the length of the tangent from point D to this circle is equal to 35 degrees. And our mission was to find out the length of the tangent from point C to this circle. Okay, so first of all, we'll define the center of this circle as O. We will define the point of tendency of the tangent from point A to this circle as E. We define the point of tendency of the tangent from point B to this circle as F. We define the point of tendency of the tangent from point C to this circle as T. And finally, we define the point of tendency of the tangent from point D to this circle as M. We join points O and E together by a straight line. Point O is the center of the circle, point E is the point of the circle itself. Therefore, OE is the radius of this circle that we define as R. And we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. We have tangent AB that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. Therefore, tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Okay, so we have tangent O, the radius OE, it is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. We will join points A and O together by a straight line. Here, by joining points A and O, we actually created here the green triangle AOE. So, we will implement the Pythagoras theorem on the green triangle AOE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the green triangle, triangle AUE, by PT is a relation for Pythagoras theorem. AO square will be equal to OE square plus AE square. Repeat again. In the green right triangle, triangle AOE, according to the Pythagoras theorem, AO square equals to OE square plus AE square. So AO square equals to OE square. OE is the radius of this circle, that is to say it is equal to R, therefore OE square is R square plus AE square. AE equals to 33 units, therefore AE square is 33 square. So in conclusion, found out that according to equation number 1, AO square equals to R square plus 33 square. In the next step, we will join points O and F together by a straight line. Point O is the center of the circle, point F is the point of the circle itself. Therefore, OF is the radius of the circle that is equal to R. We join points B and O together by a straight line. And we will implement the Pythagoras theorem on the yellow triangle, triangle OBF. Here actually the radius OF, it is drawn to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. Therefore the yellow triangle is a right triangle. So according to the Pythagoras theorem, we get that in the yellow triangle BO square equals to OF square plus BF square. Repeat again, in the yellow right triangle, BO square equals to OF square plus BF square. So BO square equals to OF square. OF equals to R, therefore OF square equals to R square plus BF square. Here BF equals to 85, therefore BF square is 85 square. In conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. In the next step, we will join points O and T together by a straight line. Point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of the circle that is equal to R. And we have the radius OT that is known to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. So here we will implement the Pythagoras. We will join points O and C together by a straight line. And we will implement the Pythagoras theorem on the green, on the orange triangle OTC. This orange triangle OTC. According to the Pythagoras theorem, in the orange triangle OTC, CT squared equals to OT squared plus OC squared. Repeat again, in the orange triangle according to the Pythagoras theorem, we get that CT squared equals to OT squared plus DC squared. Okay? CT equals to X, therefore CT squared is X squared. It is equal to OT squared. OT equals to R, therefore OT squared is R squared plus actually here the hypotenuse is CO, so here according to the Pythagoras theorem we get that CO squared equals to OT squared plus TC squared. OT squared plus TC squared. Repeat again. According to the Pythagoras theorem in the orange triangle, the hypotenuse in the orange triangle, the hypotenuse is CO, therefore the square of the hypotenuse is CO squared, that is equal to OT squared plus CT squared. So CO squared equals to OT squared. OT is R, therefore OT squared is R squared plus TC squared. TC is X, therefore TC squared is X squared. So in conclusion, found out that according to the Pythagoras theorem in the orange triangle, CO squared equals to R squared plus X squared. Okay. In the next step, we will join points O and M together by a straight line. So here, point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that is equal to R. In the next step, we join points O and D together by a straight line. here we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. So, in the next step, we'll implement the Pythagoras theorem on the pink triangle MOD. According to the Pythagoras theorem, we get that dO square, the square of the hypotenuse, equals to dm square plus MO square. So dO square equals to dm square. dm is r, therefore dm square is r square plus dm square. dm is 35, therefore the dm square is 35 square. Actually, OM is r, therefore OM square is r square. dm is 35, therefore dm square is 35 square. So in conclusion, found out that according to equation number 4, dO square equals to r square plus 35 square. In the next step, I will copy the 4 equations that we got from Pythagoras theorem. So here 4 equations. The first equation is that AO square equals to r square plus 33 square. The second equation is that BO square equals to OF square. BO square equals to r square plus 85 square. The third equation is that CO square equals to r square plus x square. And finally, the fourth equation is that dO square equals to r square plus 35 square. Okay. In the next step, I will copy the rectangle ABCD if it's circle, and we will make 2 constructions inside rectangle ABCD. So actually, this is rectangle ABCD that they copied from the original drawing. Here I will make two constructions from the center of this circle, that is to say from point O. We will draw perpendicular on BC. So here this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as T, and because of the fact that in any rectangle the opposite sides are parallel to each other, it means that side BC is parallel to side AD, and therefore if we draw here perpendicular to BC, that perpendicular must also perpendicular to side AD that is parallel to side BC. Because of the fact that AD is parallel to BC, the perpendicular on BC must also perpendicular on AD, because AD is parallel to BC. So here this angle is actually equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AD as L. In the next step, from point O, we draw perpendicular on AB. So here, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB as point S. So here, because of the fact that side AB in rectangle ABCD is parallel to side DC, therefore the perpendicular from point O that is perpendicular to AB must be also perpendicular to DC that is parallel to AB. So here we can write down that this angle also equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and DC as H. Okay. We know that all the angles inside the rectangle are right angles, that is to say all the angles of rectangle ABCD are right angles, so this angle equals to 90 degrees. This angle, it is also equal to 90 degrees. This angle is equal to 90 degrees. And finally, this angle also equals to 90 degrees. So inside quadrilateral ASOL, inside this quadrilateral, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, and therefore this fourth angle must be also equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral to 360 degrees, this angle must be equal to 90 degrees. Okay. Likewise, exactly for the same reason, if we focus on quadrilateral LODH, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. Likewise, in quadrilateral SBTO, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. And finally, Inside quadrangle OTCH, we have 1, 2 right angles. Therefore, this fourth angle must be also equal to 90 degrees. Okay. We will define side AL as H1. We will define side LD as H2. We will define side AS as B1. And we will define side SB as B2. We also note that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle ASLO, in this rectangle, the opposite sides are equal to each other. That is to say, side AS equals to side LO. But AS equals to B1, therefore LO must be also equal to B1. Likewise, in rectangle LODH, the opposite sides are equal to each other. That is to say, side LO equals to side DH. But LO equals to B1, therefore the edge must be also equal to B1. And in rectangle ASLO, side AL equals to side SO. But AL equals to H1, therefore SO must be also equal to H1. Likewise, in rectangle LODH, LD must be equal to OH, but LD equals to H2, therefore OH must be also equal to H2. And here, in rectangle SBOT, side SB equals to side OT, but SB equals to B2, therefore OT must be also equal to B2. Likewise, in rectangle OTHC, OT equals to B2, therefore HC must be also equal to B2. Likewise, in rectangle SBOT, SO equals to BT, but SO equals to H1, therefore BT must be also equal to H1. And finally, here in rectangle OTHC, OH equals to TC, but OH equals to H2, therefore TC must be also equal to H2. Okay, so in the next step, we will join points A and O together by a straight line. And we will focus on triangle ASO. This triangle, according to the Pythagoras theorem, B1 square plus H1 square equals to AO square. Okay, so AO square, and this triangle ASO, AO square equals to B1 square plus H1 square. We join points B and O together by a straight line. And we'll focus on triangle SBO. In the right triangle SBO, OB square equals to H1 square plus B2 square. OB square equals to B2 square plus H1 square. We join points O and C together by a straight line. So in triangle OTC, this right triangle, OCO square equals to B2 square plus H2 square. CO square equals to B2 square plus H2 square. And finally, we will join points O and D together by a straight line. We'll focus on the right triangle, triangle OHD. In this right triangle, DO square must be equal to B1 square plus H2 square. Okay, so here we created 4 more formulas for AO square, BO square, CO square, and DO square. So in each we have 2 different expressions for AO square, we have 2 different expressions for BO square, we have 2 different expressions for CO square, and finally we have also 2 different expressions for DO square. In the next step, we create another 4 formulas. Here, AO square, according to the first expression here, or first equation, must be equal to AO square according to the second expression. That is to say, AO square according to the first equation is R square plus 33 square, and it must be equal to AO square according to the second expression or second equation, that is B1 square plus H1 square. Likewise, we create second equation. BO square according to the first equation must be equal to BO square according to the second equation. BO square according to the first equation is R square plus 85 square, and it must be equal to BO square according to the second equation, that is equal to B2 square plus H1 square. Likewise, CO square according to the first equation must be equal to CO square according to the second equation. CO square according to the first equation is R square plus X square. It must be equal to CO square according to the second equation, that is B2 square plus H2 square. And finally, DO square according to the first equation must be equal to DO square according to the second equation. DO square according to the first equation is R square plus 35 square, and it must be equal to DO square according to the second equation, that is B1 square plus H2 square. Okay. In this way, we created here 4 equations. So in the next step, we subtract equation number 2 from equation number 1. Equation number 2 from equation number 1. Here, equation number 2, we have here R squared plus 85 squared minus equation number 1, that is actually R squared plus 33 squared. So we finish with this side of the equations. And here we subtract the second side of equation number 2 from the second side of equation number 1. So here we have B2 squared plus H1 squared in equation number 2 minus equation number 1, that is B1 squared plus H1 squared. Okay, and we define this equation as equation number 5. Now we will open the brackets. On equation number 5, we get that R squared plus 85 square. So we have minus before the bracket, so here it will be minus r square minus 33 square, that is equal to b2 square plus h1 square. Here we have minus before the bracket, so here it will become to minus b1 square minus h1 square. Here r square minus r square is 0, so r square will get cancelled. And we have h1 square minus h1 square, that is 0. So what is left from equation number 5, after we cancelled those two expressions, what is left is actually we have here, according to equation number 5, we get that 85 square minus 33 square is equal to b2 square minus b1 square. Okay. In the next step, we'll subtract equation number 4 from equation number 3. Equation number 4 from equation number 3. And we get here, and this will be equation number 6. Here, equation number 3, we have here r square plus 35 square minus equation number 3, we have here r square plus x square. We finish with this side, and then we subtract the other side of equation number 4, that is b1 square plus h2 square minus equation number 3, that is b2 square plus h2 square. In the next step, we will open the brackets of the equation number 6, and we will get that according to equation number 6, r square plus 35 square. Here we'll open the bracket, so it will become minus r square minus x square, that is equal to b1 square plus h2 square. We have minus before the bracket, so it will become minus b2 square minus h2 square. So here we have r square minus r square is 0, so r square will get cancelled. And we have h2 square minus h2 square, that is 0. So what is left from equation number 6 after we cancel those two expressions? In this side of the equation we left only with 35 square minus x square, that is equal to b1 square minus b2 square. So here we will multiply this equation number 6, by minus 1, and we get that according to equation number 6, x square minus 35 square equals to b2 square minus b1 square. In the next step, we create equation number 7. Equation number 7 states that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. So b2 square minus b1 square according to equation number 5 equals to 85 square minus 33 squared, and it must be equal to b2 squared minus b1 squared according to equation number 6, that is equal to x squared minus 33 square minus 35 squared. Okay, in the next step we will add 35 squared to this equation number 7, and we will get that according to equation number 7, x squared equals to 85 squared plus 35 squared minus 33 squared. So in conclusion, we found out that according to equation number 7, x squared equals to 85 squared. 85 squared equals to 7,225 minus plus 35 squared, that is equal to 1,225 minus 33 squared, that is 1,089. So actually we found out that according to equation number 7, x squared equals to 7,225 plus 1,225 is equal to 8,450 minus 1,089. So x squared equals to 8,450 minus 1,089 equals to 7,361. So here we take out of this equation number 7, and we get that according to equation number 7, x equals to the square root of plus minus the square root of 7,361. Okay, but because of the fact that x is a length, it must be a positive number. So we take only the positive root of 7,361. And the positive root of 7,361 is equal to plus 85.796 units. So we found out in conclusion, the answer to the question is that the length of this line segment X is equal to 85.796 units. So we finished with the first question. In the next step, I will present to you the second question. So in the drawing we have a semicircle. We know that the diameter AB of this semicircle is equal to 6 units, angle CAB equals to 30 degrees, and our mission is to find out the value of the green area. First of all, we will define the center of this circle as O, of this semicircle as O. The diameter is 6 units and the radius must be half of it. That is to say, the radius is 6 over 2, that is 3 units. AO, that is the radius of this semicircle, is equal to 3 units. OB, that is also the radius, is equal to 3 units. And OC, it is also the radius because point O is the center of the semicircle, point C is the point of the semicircle itself. Therefore, OC is the radius of the semicircle, that is equal to 3 units. So here, by joining point C and O together by a straight line, we created here triangle AOC. Triangle AOC, side OC equals to side AO. They are both equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal angles, in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front the equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle that is equal to it must be also equal to 30 degrees. So inside triangle AOC, we have this angle equals to 30 degrees, this angle equals to 30 degrees, 30 degrees plus 30 degrees is 60 degrees. Therefore, the missing angle must be equal to 120 degrees in order to complete the sum of the angles in triangle AOC to 180 degrees. This angle must be equal to 120 degrees. What is the area of a sector? Actually, the area of any sector, if we have, for example, this sector, it could be any sector, so here the two legs of the sector are the radii of the circle. So if the radius of the circle is r, then the two legs, they are both the radii of the circle that consists the sector, and the angle between the two legs, or the two radii, is theta. Then the area of this sector, sector A or B, the area of sector A or B, this is the sign of the area of a sector. The area of this sector, sector A or B, will be equal to the area of the circle that is pi r squared times theta over 360 degrees. Okay. The ratio of theta over 360 degrees gives us the relative percentage that this sector occupies out of the whole circle, and when we will multiply this percentage by the area of the entire circle, we will get exactly the area of the sector, sector A or B. So the area of the sector A or B equals to pi r squared, that is the area of the circle, times theta over 360 degrees. That gives us the ratio that this sector occupies out of the entire circle. In this, so we use this formula in order to find out the area of sector AOC, the area of this sector. What is the area of sector AOC according to the formula that I presented to you? The area of sector AOC will be equal to the area of the circle that is pi r squared, but r equals to 3, so it is pi 3 squared times the angle between the legs of the sector, that is 120 degrees, over 360 degrees. 3 squared is 9, so here this expression equals to 9 pi. 120 degrees over 360 degrees is 1 over 3. So it is divided by 3. 9 pi, 9 over 3 is 3, so in total it is 3 pi. So we found out that the area of sector AOC, the area of this sector AOC is equal to 3 pi square units. And what is, I will present to you a formula for the area of any triangle, a new formula. Here we have, if we have triangle ABC, that could be any triangle. This is triangle ABC. We know that the length of side AB is equal to A units, side AC equals to B units in its length, and the angle between side AB and side AC is theta. Then the area of this triangle ABC, according to the new formula, will be equal to A times B times sinus theta over 2. I'll repeat again, the area of this triangle ABC will be equal to A times B times sinus theta over 2. We'll use this formula in order to find out the area of triangle AOC. According to the new formula, the area of this triangle AOC, so I will copy triangle AOC in the new page and we'll find the area of this triangle AOC. So this is triangle AOC that they copied from the original drawing. According to the new formula, the area of this triangle AOC will be equal to 3 times 3 times sinus 120 degrees over 2. Repeat again, the area of this triangle AOC, the green triangle, will be equal to 3 times sinus 120 degrees over 2. 3 times 3 is 9. Sinus 120 degrees is equal to 3 over 2, all divided by 2. So it is 9 times square root of 3, and 2 times 2 is 4. So in conclusion, we found out that the area of the green triangle AOC is equal to 9 times square root of 3 over 4 square units. And we have already found out that the area of sector AOC equals to 3 pi square units. The area of sector AOC equals to 3 pi square units. Okay, but what is the area of the green shape. From the drawing, it is very easy to see that the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. I repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. Here, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC, that is equal to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to 3 pi minus 9 times square root of 3 over 4 square units. That is about 5, it is about 5.5 about 5.5 square units in terms of numbers. Okay, we'll see it here. 3 times pi is 9.4248 minus root of 3 over 4 times 9, it is 3.897 minus 9.4248. The area equals to, in terms of numbers, it is equal to 5.528 square units. Repeat again, the area of this green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, so in terms of numbers, it is equal to 5.528 square units. In the next step, I will present to you a second method to find out the area of the green shape. The area of this green shape is equal actually to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Again, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. So I write it down. In the second method, we use this formula in order to find out the area of the green shape. The area of the green shape, according to the second method, will be equal to the area of the semicircle minus the area of triangle AOC minus the area of this sector, sector COB. I'll repeat again. According to the second method, the area of the green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. So what is the area of the semicircle? The area of the semicircle is equal to the area of the circle, that is pi r square over 2. R equals to 3, so it is pi times 3 square over 2. 3 square is 9, so it is 9 pi over 2. So we found out that, in conclusion, that the area of the semicircle equals to 9 pi over 2 square units, and we already found out that the area of triangle AOC in the first method is equal to 9 times 4 to 3 over 4 square units. So use it in the second method. Now we'll calculate the area of sector COB. What is the area of this sector, sector COB? According to the formula that I presented to you, the area of this sector, sector COB, here we know that AB is a diameter of the semicircle. It is absolutely a straight line. AB is a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees. So which angles we have in the upper side of AB at point O? This angle equals to 120 degrees, plus the missing angle. In total, they must be equal to 180 degrees. So in order that the sum of the angles on the upper side of AB at point O will be equal to 180 degrees, this angle must be equal to 60 degrees. Okay? So what is the area of sector COB? The area of sector COB, according to the formula that I presented to you, equals to the area of the circle, that is pi r square, times the angle between the legs of sector COB, that is 60 degrees, over 360 degrees. I repeat again, the area of sector COB equals to the area of the circle, that is pi r square, times the angle between the legs of sector COB, that is 60 degrees, over 360 degrees. R equals to 3, so r square is 3 square, so in total this expression equals to 9 pi. 60 degrees over 360 degrees is 1 over 6. So here we divide it by 6. Here we divide both the numerator and the denominator by 3. 9 over 3 is 3. So here in the numerator we have 3 pi. And here 6 over 3 is 2. So in conclusion, we found out that the area of sector COB is equal to 3 pi over 2 square units. Okay, now the only thing that is left to do is to put the values that we found for the areas of the semicircle, the area of the triangle, and the area of the sector COB inside the formula for the area, and we find out the area of the green shape. So I repeat again on the formula for the area of the green shape. The area of the green shape is equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. repeat again on the formula for the area of the green shape. The area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle is equal to 9 pi over 2. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4. And finally, we have already found out that the area of sector COB equals to 3 pi over 2. Okay? So here we have 9 pi over 2 minus 3 pi over 2 equals to 6 pi over 2. And we have left here minus 9 times root of 3 over 4. 6 over 2 is 3. So here we have this expression in total equals to 3 pi minus 9 times root of 3 over 4. So we found out that according to the second method, the area of the green shape equals to either 3 pi minus 9 times root of 3 over 4 square units, or in terms of numbers, it is equal to 5.528 square units. Okay, so we finished with the second question. In the next step, I will summarize the lecture. We'll start with the first question, of course. So in the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle. We know that the tangent from point A to the circle is equal to 33 units in its length. The tangent from point B to this circle is equal to 85 units in its length. The tangent from point C to this circle is equal to X unit. That is the length that we are looking for. It is unknown, and we want to find out the length of the tangent from point C to this circle, or the value of line segment CT. And finally, we also know that the tangent from point D to this circle is equal to 35 degrees, or line segment DM equals to 35 degrees. And our mission is to find out the length of the tangent from point C, or the length of line segment CT. Okay? So, first of all, we define the center of this circle as O. Then we join points O and D together by a straight line. Point O is the center of the circle, point E is the point of the circle itself. Therefore, according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. This angle will be equal to 90 degrees. We join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is the radius of this circle that is equal to R. We have the radius OM that is drawn to the point of tendency. Therefore, this angle equals to 90 degrees. Likewise, we join points O and T together by a straight line. OT is the radius. We have the radius OT that is drawn to the point of tendency. Therefore, this angle equals to 90 degrees according to rule number 1. Then we join points O and F together by a straight line. OF is the radius that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. Then we join points A and O together by a straight line. By this way, we created the right triangle, triangle AOE. The right triangle AOE, according to the Pythagoras theorem, AO square equals to EO square plus EA square. Then we join points P and O together by a straight line. In this way, we created the yellow triangle. We implemented the Pythagoras theorem on the yellow triangle. According to the Pythagoras theorem, BO square equals to OF square plus FB square. Then we joined points C and O together by a straight line. In this way, we created the orange triangle. We implemented the orange right triangle and we implemented the Pythagoras theorem on the orange right triangle, triangle OCT. According to the Pythagoras theorem in the orange right triangle, OC square equals to OT square plus TC square. And finally, we joined points D and O together by a straight line. In this way, we created the pink triangle, triangle OMD. According to the Pythagoras theorem in the pink triangle OMD, OD square equals to OM square plus MD square. Okay. So in this way, we created 4 equations by implementing 4 times the Pythagoras theorem. The first time in the green right triangle, then in the yellow right triangle, then in the orange right triangle, and at the end in the pink right triangle. We created here 4 equations for the 4 equations. Those are the 4 equations that we created here. But then I copied the right triangle, rectangle ABCD in a new page. This is the circle that is inside triangle rectangle ABCD. I did 2 constructions here. From the center of this circle that is to shape from point O, we draw perpendicular on AB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then the straight line that is perpendicular to AB must be also perpendicular to DC. Why? Because AB is parallel to DC. Therefore, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then from point O, I draw perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then the perpendicular to BC is also must be perpendicular to AD. Why? Because AD is parallel to BC. So this angle also equals to 90 degrees and this angle also equals to 90 degrees according to our construction. And we know that all the angles inside rectangle ABCD are right angles. So here inside quadrangle ASLO we have 1, 2, 3 right angles. Therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. The same thing is true in quadrangle LODH. We have 1, 2, 3 angles, therefore the fourth angle must be also equal to 90 degrees. The same thing is true about those 2 triangles, about those 2 quadrangles. So by this way, by the construction, we created here 4 rectangles. We have 4 small rectangles in the big rectangle, rectangle ABCD. And then we joined points A and O together by a straight line. And we implemented the Pythagoras theorem on the right triangle, triangle AOS. According to the Pythagoras theorem, B1 square plus H1 square equals to AO square. Then we joined points O and B together by a straight line and we implemented the Pythagoras theorem on the right triangle OBS. According to the Pythagoras theorem, b2 square plus h1 square equals to OB square. Then joint points O and C together by a straight line, and we implemented the Pythagoras theorem on the right triangle OHC. According to the Pythagoras theorem, h2 square plus b2 square equals to OC square. And finally, joint points O and D together by a straight line, and we implemented the Pythagoras theorem on the right triangle ODH. On the right triangle ODH, OD square equals to OH square plus DH square. So we implemented 4 times the Pythagoras theorem on those 4 right triangles, and in this way we actually created another 4 equations. Those are the 4 equations that we created here. So we have 2 different expressions for AO square, we have 2 different expressions for BO square, we have 2 different expressions for CO square, and we have also 2 different expressions for DO square. Then we created 4 more equations by the statements that AO square according to equation number 1 must be equal to AO square according to equation number 2. This is the first equation. Then we created the second equation that BO square according to equation number 1 must be equal to BO square according to equation number 2. Then we created the third equation that states that CO square according to equation number 1 must be equal to CO square according to equation number 2. And finally we created the fourth equation that states that DO square according to equation number 1 must be equal to DO square according to equation number 2. So those are the four equations that we created by the process that I mentioned, and then we subtracted equation number 2 from equation number 1. Then we subtracted equation number 3 from equation number 4. So by subtracting equation number 2 from equation number 1, we created equation number 5. By subtracting equation number 4 from equation number 3, we created equation number 6. And here in equation number 5, we have b2 square minus b1 square that is equal to 85 square minus 33 square. Then we multiplied equation number 6 by minus 1, and we got that x square minus 35 square equals to b2 square minus b1 square. Then we created equation number 7 that states that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. So this is equation number 7, and so according to equation number 7 we found out that 85 square minus 33 square equals to x square minus 35 square. Then we added 35 square to this equation number 7. We found out that according to equation number 7, x square equals to 85 square plus 35 square minus 33 square. Then we open the brackets on this side of equation number 7, and we found out that x squared equals to 7,225 plus 12,225 minus 1,089. 7,225 plus 1,225 equals to 8,450 minus 1,089. So 8,450 minus 1,089 equals to 7,361. So we found out that according to equation number 7, x squared equals to 7,461. We took a root out of this equation and found out that x equals to plus minus the square root of 7,361. So we have two solutions for x, the positive solution and the negative solution. But because of the fact that x is a length, x as a length must be a positive number, so we take into account only the positive solution and found out that the length of line segment x, the line segment that we are looking for, equals to 85.796 units. We finish with the first question, then presented to you the second question, and we solved the second question in two different methods. So in the drawing we have a semicircle and we know that AB is the diameter of the semicircle, that is equal to 6 units. Angle OAC, this angle equals to 30 degrees, and our mission is to find out the area of the green shape. Okay. So first of all, I presented to you a formula for the area of a sector. So if we have here sector A or B, that could be any sector, the area of this sector, sector A or B, is equal to the area of the circle, that is pi r squared, times theta, that is the angle between the legs of the sector, over 360 degrees. Pi r squared is the area of the circle, times theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire circle, and when you multiply it by the area of the entire circle, you will get exactly the area of this sector. So the area of this sector, sector A or B, equals to pi r squared times theta over 360 degrees. We use this formula in order to find out the area of this sector, sector AOC. The area of this sector, sector AOC, will be equal to pi r squared, and r is 3. Because of the fact that the diameter is 6 units, then the radius must be half of it. That is to say, the diameter must be 6 over 2, that is 3 units. The radius must be equal to 3 units. So here AO is 3 units, OC, that is the radius, is also 3 units, and OB, that is the radius, that is equal to 3 units. So what is the area of this sector, sector AOC? It is equal to pi r squared, r equals to 3, so it is pi times 3 squared times the angle between the legs of the sector. But here we know that AO equals to OC, and we have the rule that in front of equal angles in the triangle, in front of equal sides in the triangle, there are equal angles. So those two angles must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees because of the fact that they are located in front of equal angles, in front of equal sides, therefore they must be equal to each other. So those two angles are both equal to 30 degrees. 30 degrees plus 30 degrees is 60 degrees. So the missing angle must be equal to 180 degrees, 220 degrees. In order to complete the sum of the angles in this triangle, 280 degrees, this angle must be equal to 120 degrees. So the angle between the legs of sector AOC is 120 degrees. So the area of sector AOC is pi r squared, and r is 3. So it is pi 3 squared times the angle between the legs of the sector, that is 120 degrees, over 360 degrees, according to this formula. Pi 3 squared is 9 pi. 120 degrees over 360 degrees is 1 over 3. So in conclusion, we found out that the area of sector AOC equals to 9 pi over 3. 9 over 3 is 3. So in total, we found out that the area of this sector AOC equals to 3 pi square units. Okay, so we found out that the area of sector AOC equals to 3 pi square units. Then I presented to you a new formula for the area of any triangle. Here we have triangle ABC that could be any triangle. The length of side AB is A units, the length of side AC is B units, and the angle between side AB and side AC is theta. Then the area of this triangle ABC, it is A times B times sinus theta over 2. Again, the area of this triangle ABC, it is A times B times sinus theta over 2. Okay? Use this formula in order to find out the area of this triangle AOC. So I copy triangle AOC in this new page and implemented the new formula in order to find out the area of this triangle AOC. AO equals to OC equals to 3, and the angle between the AO and OC is 120 degrees. So according to the new formula, the area of this triangle AOC will be equal to 3 times 3 times sinus 120 degrees over 2. Again, the area of this triangle AOC equals to 3 times 3 times sinus 120 degrees over 2. 3 times 3 is 9, and sinus 120 degrees is square root of 3 over 2, all divided by 2. So in the numerator we have 9 times square root of 3, and 2 times 2 is 4. So we found out that the area of triangle AOC equals to 9 times square root of 3 over 4. And we have already found out that the area of sector AOC equals to 3 pi. Yeah. We already found out that the area of sector AOC equals to 3 pi square units. So what is the area of the green shape? The area of the green shape, it is very easy to see from the drawing that the area of the green shape, this green shape will be equal to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC will be equal to the area of the green shape. I'll repeat again. The area of the green shape will be equal to the area of sector AOC minus the area of triangle AOC. We already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to 3 pi minus 9 times square root of 3 over 4 square units. Or in terms of numbers, it is equal to 5.58 units. Again, in terms of numbers, the area of the green shape equals to 5.528 square units. Then I presented to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. Again, the area of the semicircle minus the area of triangle AOC minus the area of sector BOC equals exactly to the area of the green shape. I repeat again on the formula. The area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. The area of the semicircle is pi r square over 2. R equals to 3, so pi r square is pi times 3 square divided by 2. 3 square is 9, so in total this expression equals to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And finally, what is the area of sector COB? The area of sector COB, here, you know that AB is the diameter of the semicircle, therefore it is absolutely a straight line. And you know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of AB at point O, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point O? We have this angle that is equal to 120 degrees, plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. So here the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. So we found out that the angle between the legs of sector COB must be equal to 60 degrees, and OB equals to 3, and OC equals to 3. And therefore, the area of sector COB will be equal to pi r squared times 60 degrees over 360 degrees. 60 degrees is the angle between the legs of sector COB. R is 3, so r squared is 3 squared. 3 squared is 9, so in total this expression equals to 9 pi. 60 over 360 is 1 over 6. So in total this expression equals to 9 pi over 6. Here we divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3. So this in the numerator we have in total 3 pi. 6 over 3 is 2. So in the denominator we have 2. So in total we found out that the area of sector COB equals to 3 pi over 2. The area of sector COB equals to 3 pi over 2 square units. And the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. That is to say, we have already found out that the area of the semicircle equals to 9 pi over 2 square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And we just right now found out that the area of sector COB equals to 3 pi over 2 square units. Okay? So we have 9 pi over 2 minus 3 pi over 2 is 6 pi over 2. So in total this expression equals to 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi. So in total we found out in conclusion that the area of the green shape equals to, according to the second method, equals to 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers it is equal to 5.528 square units. Again, the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers it is equal to 5.528 square units. Okay, thank you very much.